Okay, today we'll be talking about applications of trigonometry. Okay, now in this chapter, we will see that where exactly trigonometry is used. So, okay, let's get started. Okay, now this is important. We need to understand this key type of thing in the beginning because we'll be using all this. For a given triangle ABC, we shall use A, B, C. This is small a, small b, small c to denote the measures of sides and ABC to denote the measures of angles. The quantities ABC are called the elements of the triangle. Now, in this chapter, using trigonometry, we'll be finding out different elements of triangle. It could be any side, it could be any angle, okay? But we know we use trigonometry, we use sine, cos, tan, we use different formulas and all that is trigonometry. This is why this chapter is called applications of trigonometry. Okay. Okay, so here it is. We have different types of triangles. We have scalene, isosceles, equilateral, acute, obtuse, right, and oblique. Okay. If we talk about scalene, all the three sides are different and all the three angles are different. If I talk about isosceles, two sides are same. So according to the angle side relationship, as I've told you earlier as well, if we have two same sides, two angles would be same, right? We use this thing in circle theorem as well. Let's say this is an isosceles triangle. So this side and this side is same. Then this angle and this angle is going to be same, right? This is what we call angle side relationship. So it says two sides are same, so two angles are same. In equilateral, three sides are same, so three angles are same. And if all the three angles are same, it would be of 60 degrees, okay? Each angle would be of 60 degrees. Then if I'm saying a triangle is acute, it means it could be scalene, it could be isosceles, and it could be equilateral as well. The only thing is coming here, three angles are acute less than 90, okay? So if I'm saying if any triangle is acute, all the three angles should be less than 90. It could be scalene, it could be isosceles, it could be equilateral, but the angle should be less than 90. If I'm saying obtuse, then it could be scalene or isosceles, but not equilateral because one angle should be obtuse. Okay, one angle is obtuse. It should be greater than 90, but it should be less than 180. It cannot be equilateral. Why? Because in case of any equilateral triangle, all the three angles are 60 degrees. So for obtuse, we need one angle to be obtuse. For right angle, we know these triangles. For the right angle triangle, one angle should be 90 degrees. And for oblique, we have, it could be scalene, it could be isosceles, but no angle is 90 degrees. That is it. That is the only condition here, okay? So it could be acute as well. It could be obtuse as well, but it cannot be right angle triangle. That is it, okay? So I'll quickly sum it up. We use trigonometry in triangles for finding out different elements of any triangle. When I say elements, it could be any angle, it could be any side. We have different types of triangles, scalene, isosceles, equilateral, acute, obtuse, right, and oblique, okay? So I suppose that this is clear. Okay, let's talk about the next thing. Okay, now if the question is about finding any element of the triangle, it could be a side, it could be any angle, what do we use? We use trigonometry. And when we say we use trigonometry, what do we use? We use different laws of sine, law of cosine, and law of tangent. Okay, we are using these different rules. So let's try understanding them. Okay, so I suppose that you guys would be familiar with this one and this one, but I guess that this might be new. But let's see, okay? All these small letters A, B, C, they are denoting the sides, and capital A, capital B, and capital C, they are denoting the angles. So let's make a triangle first. A, B, and C. So this is angle A. The side opposite to angle A would be small a. The side opposite to capital C would be small c. And the side opposite to capital B would be small b. Okay. This is what you need to understand. All these A, B, C are coming like this. It could be any triangle. It could be obtuse. It could be scalene. It could be right angle. But the idea is same. The side opposite to any angle is denoted with small letter. Okay. That is it. Okay. Now when we say law of sines, what do we have? We have a side divided by sine of opposite angle. Then we have B divided by sine of opposite angle. And then this should be C divided by sine C. Okay. Where do we use law of sines? Now, law of sines could be used for finding the side, or it could be used for finding the angle. It depends on the situation. Okay. Let's talk about an example here. So let's say this side is 21 meters, for example, and this angle is 60 degrees. Okay. Then this angle is, for example, 55 degrees, and you are interested in small a. What exactly we are going to use? We will use the first two ratios only. We do not need the third one in this case. So let's just ignore this. We don't need this one. Okay. Now please pay attention. A, I do not have A. So A divided by sine capital A is 55 degrees. So sine 55 equals, what is small b? Small b is 21 divided by sine 60. Okay. Now we need to solve this. I can take this to the other side, and A is going to be 21 sine 55 divided by sine 60. Okay. Now we'll be using our calculators for solving it. Yes, Saad and Ahmed, can you guys solve it and tell me the answers? I want you to participate. It should be 19.9 meters. Okay. So A would be 19.9 meters, and that makes sense as well. So A is 19.9 meters. Okay. And why is that making sense? For 60 degrees, it is 21. So 55 is not very different from 60. So the change should also be a minor change, right? So this turned out to be 19.9. Okay. Similarly, you could have, used this for finding any angle as well. So let's not get into the details because we'll be doing questions. Let's talk about the law of cosine. Okay. Now, what exactly is this? Okay. Now, the best thing about these three formulas is this, that you can use them for all the scenarios. Like you can use them for a right angle triangle as well, for scalene, oblique, isosceles, acute, for all the triangles, right? They are not the trigonometric ratios which are only used for the right angle. That is the best thing about them. So these are your three formulas which you can use whenever you have any triangle that is that does not have the 90 degrees angle as well. Okay. What is the law of cosine? So obviously if it says law of cosine, it is going to have cosine in it. And yeah, this and this. Okay. What exactly it is saying? So I suppose that you guys would be comfortable with this. If not, then these formulas should be at your fingertips. So it says a squared equals b squared plus c squared minus 2bc cos a. Whatever alphabet is coming here, we have cos of that. Okay. and then the other two sides are coming here this way. So a squared plus b squared, then we have a minus in cosine. Always remember, this is minus 2ab cos c. Whatever way you want to memorize, but you need to memorize these formulas, okay? And this and this, they have just made cos a, cos b, cos c the subject. So it is good that you remember the first one and this one, okay, and this one, and that is it. You would be able to make up all the other on your own, so there's no point in memorizing them. I know that you can make cos a the subject in exam, but I'm telling you, honestly speaking, I've given NET myself as well, you would not be having this much time, okay? So if you have all the three sides and the question is about finding any angle, you should just know which formula to be used, okay? So you'll be using cosine, law of cosine. Okay, now you need to be careful that if you are interested in finding out cos b, the order of these numbers would be different. If it's cos b, you would have 2ac in the denominator, you would have a square plus c square, and then minus b square. Okay, so whatever the number is, forget about it initially, just put a division sign, 2, and then the other two sides ab, then the square of the other two sides, a squared plus b squared, and then minus a squared. Okay, I'm just trying to help you with the memorization thing. If you can, then that's perfect. Just try memorizing it as soon as you can. Okay, so this was the second one, and here's the third one, the law of tangents. Okay, so what is this? This is basically giving you information about the ratio of a minus b divided by a plus b. Okay, now for these questions, honestly speaking, we do not use the law of tangents a lot. Yes, you can use them for such scenarios. Let's say you've been asked to find tan a plus b by 2. Okay, so for such things you can use them, but still you should have them in your mind, and you'll see in questions you would not be using them a lot. Okay, so yes, again the pattern is same. Small a, small b, small c, they are denoting the sides. Capital A, capital B, capital C, they are denoting the angles. Okay, so if we talk about the first one, it says a minus b divided by a plus b. So again, in the numerator we have a minus b divided by 2, and then a plus b, right? So you will see some sort of symmetry in these formulas. You just need to learn one, and you would be able to write down all of them easily. Okay, so yes, any doubts with first two slides? Saad and Ahmed, is this okay?
Yes, ma'am.
Okay, very good. And what about you, Ahmed? Yes, Ahmed, any doubts? Okay, Ahmed is typing. Okay, very good. All right, so I think that it would be a bit boring as well, but please, you need to do this. So yeah, okay. What is next? Next is the half angle formulas. Now, I'm pretty sure that Ahmed would think we have done half angle formulas, but we have done like a different form. For example, I'll write it down. Let me see if I can quickly take out the table. All right, okay. Let's write it down one here. Okay. Now, how do we do it? So we are used to writing down the half angle formulas this way. Let's say we have sine theta by 2. So we do it this way, under the root, and then 1 minus cos theta by 2. Okay. Now, Ahmed and Saad, this form and this form, they are equivalent. Both of them are giving you information about the half angle. The only thing is you need to decide for which situation you need to use this one, and then for which situation you need to use this one, because this decision would vary from question to question. Okay, if the question is about the angle, or about all of that, then you can use the first one, you can use this one, and you will use these for solving different identities. Okay, we will talk about that chapter next week about trigonometric identities. But yes, since I know When we talk about half angle formulas, this is what comes to anyone's mind. Yes, this is also half angle formula, and all of them are also half angle formulas because they are also half angles. Okay, we use them for solving trigonometric identities. But at the moment, we're talking about applications of trigonometry. When we say applications, we are basically saying where exactly is trigonometry used. Trigonometry is used for finding different elements of any triangle. When I say element, it could be any side, it could be any angle. Okay, so that is why we are learning all these formulas. Okay, so yes, forget about this at the moment and let's talk about that. Okay, let me zoom out. All right, just give me 1 second. Okay, I'm sorry, I'm back. Okay, so now we are done with the laws of sine, cosine, and tan. And now we need to talk about the half angle formulas. Okay, but this time around, the half angle formulas are different. They're not the previous ones, the ones which you have already studied. They are different, and we will use them for finding different elements of a triangle. Okay, very good. Let's do it quickly. Okay, now what exactly is this? So let me make a triangle again. Again, let's say this is A, B, and C. This side would be small a, this side would be small b, and the side opposite to angle C would be small c. Okay. So we have capital A, capital B, capital C. We have small a, small b, small c. What exactly is this S? So this S is basically A plus B plus C divided by 2. This S is half of the perimeter of your triangle. Okay. What is perimeter of any shape? It is sum of all sides. So if I talk about this triangle, it would be A plus B plus C. When I'm saying S, for S, you're just dividing it by 2. So this is basically a quantity which we use in half angle formulas for finding things. Okay, let's see. Now let's suppose that you have been asked to find the angle A and you have ABC. Okay, you have three sides and you need to find, let's say, all the angles A, B, and C. These are the formulas which you can use. Okay, yes, you can use the cosine rule as well. That is completely your choice, but you can use these as well. That is your choice. Okay, whatever formula you are comfortable with, you can use them. All right. Okay, so let's say this side is 2, 2, and 3. Okay, this is a triangle, two sides are same. Let's suppose this is an isosceles triangle then, and then we have another side 3, and you need to find the angle B, let's say. Okay, so we can use any formula. We can use sine, cos, tan. Let's start with this one. Okay, so I'll write down sine of B by 2 equals under the root divided by, okay, S minus A. So what is S? S is 2 plus 2 plus 3 divided by 2. So it would be 7 divided by 2. So it is 3.5. So it is 3.5 minus B. B is, okay, minus A. Sorry. A is 2. Then again 3.5 minus C, that is 3. Now, one thing should be clear that they are not going to use the side B here. Okay, this is how you can remember these. divided by AC. So it is 2 and 3. That would be 6. Okay. Can you guys please simplify this and tell me the answer? What would be the answer? Yes, please do that. Okay, so we have under root and then we have 3.5 minus 2. So that would be 1.5 into 0.5 divided by 6.
Ma'am, I'm getting 0.35 answer.
Yes, that is correct. Okay, very good. This is 0.354. Okay. Now you will do sine inverse and this value, and it is going to be 20.7 degrees. Okay. This is for b by 2. So b over 2 has turned out to be 20.7. What would be the value for b? It would be 2 multiplied by 20.7. So b is going to be 41.4. Okay. Now for this question, we were using our calculators because this is how the question was. And at the moment, we're not doing past paper questions. We're just practicing. So it is okay. But obviously in NET, the question would be of this type that you would not be using your calculators. Okay. Now one might think that how is it possible that without using calculator, we can find the values of sine inverse and sine? So for that, I think I had a demo class with a student and I shared the recordings on the group. There I told him when we were doing a specific chapter, I think it was the first chapter of trigonometry, that there's a proper table which was there in the on the in the slides. You need to use that. You need to remember that table for NET. Yes, I'm not kidding. You need to remember that table, and that is why I'm telling you guys to start preparing from now. Just get it printed, paste it in your room somewhere just so you get to see it again and again, because otherwise you would not be able to do it. Okay, you need to have all those values in your mind. If we talk about the basic graph of sine, cos and tan, yes, they can also help you, but they do not have all for all the angles. Okay, so those tables they basically have for all the angles, and you need to remember that. And it is not that difficult, trust me. It looks like it is very difficult, but it is not. I suppose it has 7 rows and 8 columns, something of that type, right? So you can remember 56 entries, stuff like that, and inshallah you would be able to. So do not worry. Okay, so this is all about half angle formulas we use for B. You can use cos, you can use tan, you can use any. You can see the pattern is same, only the arrangement of variables is different. Okay, so again, just remember 1, 2, and 3, and you would be able to do it easily. Okay, and yes, I do understand that if the question is about finding A, so there's no point in remembering all of them. You can just use the first one. But the question could be about this specifically, that find the ratio for tan A by 2, stuff like that. So for that, you will be using this. Okay. So you need to remember these formulas. If you know these formulas, you would be able to give the test easily. It's all about formulas because the A level students are used to the data booklet, and then otherwise in both the cases we have calculators. So yes, that is a very big difference which makes us think that it is difficult, but it is not that difficult. Okay. So any doubts in this, in the half angle formulas?
No, ma'am.
Okay. All right. Now here is the third thing. Now, since we were talking about applications of trigonometry, so for finding any elements, when we say elements, it means sides and angles. We have half angle formulas, we have law of sines, law of cosine, and law of tangents. Okay. And that is it. And the next thing is you need to find the area of triangles. Okay. Now that depends. It depends on what exactly you have. Okay. So let's say you have two sides and their included angle is given. For example, you have a triangle A, B, C, small c, small a, small b. Okay. So for some scenario, you have two sides and you do not have the third side. You do not have A, but you have the angle opposite to that side A, that is capital A. Okay. So you can use this formula directly for finding the area. It is half BC sine A. Now, whenever we talk about the formula for area of a triangle, everyone thinks half base into height. Yes, that works, but that works for a right angle triangle only. Why do we get clueless when we talk about area of triangles other than right angle triangle? Okay, I've shown you we have several types, and you need to remember the formula for this just so you are able to find the areas. Okay, so this one and this one, they are just the same. We have two sides, we have the angle of the third one, you can do it. Again, two sides, angle of the third one, you can find the area. Let's see what exactly we have here. Now, this is a different one. We have one side and two angles are given. Okay. So we just have one side, but we have two angles. And if you have two angles, you can easily find the third one using which formula, that sum of angles in any triangle is 180 degrees. Okay. So in short, for the second one, you need all the three angles and you need one side. So it could be that you just have two angles, you can easily find the third one, and you have any side. So using that, you can find the area. Let's suppose we talk about this one. Let's say C is the side and A and B are the angles. Okay. So if C is the side, you're dividing it by 2 sine C, and sine A and sine B are coming in the numerator. Okay. And always remember they are squared. It's A squared, it's B squared, and it is C squared. Okay. Do not get confused with this. Yes. Okay. And the third one is important one. It says if you have all the three sides and you need to find the area. So this formula is called the hero's formula or Heron's formula. You'll find both these wordings. You can call it hero, you can call it Heron, that's your choice. All we know is that if you have all the three sides, this is how we find the area. So what are we doing? We are doing under the root S. What is S? It is half the perimeter. Okay. Under the root S into S minus A, S minus B, S minus C, and this is going to give you the area. And we call it Hero's formula. You will see a question about it. So please remember that. Okay. So this was all about finding out the area of any triangle. Now these formulas would work for right angle triangle as well. Okay. So this is the best thing about this, that these would work for any triangle. Okay. So I assume that this is clear. Let's talk about the most important thing now. Okay. Now here we have some definitions, some interpretations, and they are very easy actually. Okay. We have three different types of circles and they are some way connected to triangles. Let's see. Let's talk about the first one. It says Circum Circle. The circle passing through the vertices of a triangle is called a circumcircle. The center of the circumcircle is called the circumcenter. It is the point of intersection of the right bisectors of sides of the triangle. Now wait for a second, you won't understand it this way. What exactly they are saying? The point circumcircle is a circle that is lying inside the triangle and it is touching the vertices. Okay. The other thing is that the center of circumcircle is called circumcenter. And what exactly is the center? It is the point of intersection of the right bisectors of the sides of the triangle. So yes, okay, this one, okay. Yes, now I'm sorry. Yes, this is not lying inside. Basically, I mixed it up with the next one. Okay, this is the first type. Okay, now you are going to see three types, and in all these three types, we are basically going to see a triangle and a circle, and there would be some connection. This is the first one. We call this circumcircle. So, what is the first point? The first point was that it is the circle passing through the vertices of a triangle. Okay. So, what do we see? This circle is passing through these vertices of the triangle, and the other information was about the center. This center is called circumcenter. And what exactly is this? Where exactly is this? So basically, if you look at the triangle, it has three sides, and these three red lines, line 1, line 2, and line 3, they are the perpendicular bisectors of these three sides. Okay, so when we say perpendicular bisectors, they are making the 90 degrees angle and they are bisecting, they are dividing all the sides into two parts. Okay, so if we talk about the circumcenter is the point of intersection of L1, L2, L3. In short, all you need to remember is that we have three types of circles in this case. The first one is circumcircle. Triangle is inside the circle. The circle is passing through the vertices of the triangle A, B, and C. And the most important thing is that the center of the circle is called circumcenter, and it is being made using the point of intersection of L1, L2, L3. L1, L2, L3 are three lines, and each line is basically a perpendicular bisector for one of the sides of the triangle. Yes, any confusions with the circumcircle with the first type, Saad and Ahmed? Please feel free to ask me.
No, ma'am.
Okay, very good. And what about you, Ahmed? Yes, Ahmed. Okay. No. Okay. All right. So we are done with with the understanding. So it says the radius of circumcircle is called circum radius, and it is denoted by r. So for this circle, if you have been asked to find the radius, this is how you can find it. Okay. You would be having three sides. So it says ABC divided by 4 times area of the triangle. This triangle is basically denoting the area. Then let's say you have one side and you have the angle opposite to it, and still you are interested in finding out the radius, the circum radius. This is how you do it: a divided by 2 sine a. Similarly, if you have any side and any angle opposite to it, you can use the same formula. So for the circumcenter, we know how to find the center, we know how to find the circum radius. Okay, and this would be used in next chapters, like if we talk about the most important section for NET maths, that is the conic section. We'll be using these there a lot. Okay, so this understanding is extremely important. It is very, very important because conic section is the most important chapter for this NET. Okay, all right. Then we have in circle. If we talk about in circle, what is that? Let's try understanding through through the description. The circle is drawn inside a triangle touching its three sides is called inscribed circle or in circle. Okay. The circum circle was outside the triangle and it was touching the vertices only. The in circle is inside it says in circle. So it would be inside the triangle and it is touching the three sides. You can either call it inscribed circle or you can call it in circle. The center of in circle is called in center. It is the point of intersection of the bisectors of angles of the triangle. Okay, let's go and see where exactly is the in circle. All right, here it is. This circle is lying inside the triangle and it is touching the three sides of the triangle. Okay, that is the first thing. The second thing is, what is the center of the circle? It would be called in center. And how it is being made? It is being made by the point of intersection of these three lines. Okay, the three purple lines, I label them. So L1, L2 and L3. Okay, we're talking about these three lines at the moment. Why these three lines? Because they are bisecting the angle A, B and C. Okay, so you need to make three lines and all of them would be bisecting each angle ABC. The point of intersection would basically give you information about the center of the circle. Okay, in the previous one we were bisecting the sides of the triangle. You can see L1, L2, L3, they are bisecting the sides, but this time around they are bisecting the angle. Okay, so these are the two basic differences, and the most major one is that in circle the circle is inside, and in this one the circle is outside for the circumcircle. All right, okay, so again the discussion is similar. Next you need to find the radius. The radius is called in radius and this is how we find it. It is r equals area of triangle divided by s. So area of triangle can be calculated through any formula and s would come by adding up all the sides and dividing them by 2. All right. Okay. So this is how we do it. All right. Let's talk about X circle. What is X circle? It says a circle which touches one side of the triangle externally and the other two produced sides is called an ascribed circle or X circle. Okay, or E circle. You have multiple names. All you need to understand is that this time around the circle is touching one side externally. Okay, the centers of these circles are called X centers, are the points where the internal bisector of one and the external bisector of the other two angles of the triangle meet. Okay, let's go and see. You won't be able to understand it this way. All right. So let's zoom out. Okay. Now these three circles are basically E circle, X circle, or X-type circle. Okay, it's completely your choice, whatever you want to call them. But all of them, you have three examples at the moment. Okay, so what do we see? We see that each circle is touching one of the sides of the triangle, and this is what the definition says. It says a circle which touches one side of the triangle and the other two produced sides is called ascribed circle, X circle, or E circle. Okay. All you need to remember is the distinction in these three, how to find the center. Okay. Now that would not be just easy because it would be a time taking process. So the examiner might not ask you to find the circumcircle. Yes, we will talk about three different formulas for finding the circumcircle when we get to the conic section. So we'll talk about that over there. At the moment, all you need to remember is how to find the radius. Okay, the radius is very important. So what do we have here? The radius of x circle opposite to the vertex A, B, and C are denoted by R1, R2, R3. Okay. So when we'll talk about x circle, we'll basically be talking about three triangles. Okay. Because we have one triangle and then that one triangle has three sides. So around all the three sides, we'll be having three circles. Okay. This is what you need to understand. All right. So we will have R1, R2, and R3. Okay. So let's say you are interested in finding out R1, what are you going to do? You will talk about the area of the triangle divided by S minus A. Okay. Let's say we're talking about R2. Again, you can talk about the area divided by S minus B. And if we talk about R3, it would be same. Okay. Triangle divided by S minus C. Just read this line once again. The radii of x circles opposite to the vertex A, B, and C are denoted this way. This is the triangle. This would be the radius of A. This is the radius of B. And this is the radius of C. Okay. So do not get confused. We just have one triangle here. Okay. So we'll be finding out the area and the selection of formula would depend on which triangle they're talking about. Okay. Let's say they are talking about R3. Okay. So what is this? R3 would be opposite to the vertex A, B, and C. Okay. It would be opposite to C. And this is going to be the formula. Okay. This is the triangle. And the formula is area of the triangle divided by S minus C. Okay. Now, please pay attention. We're talking about X circles and it would depend. Okay. It could be that you have one circle. It could be that you have two circles. It could be that you have three circles. You need to be careful about the position of the circle and that is it. Okay. Let's say you have been asked to find this R3. How do we do it? You need to see that which side exactly of the triangle is touching your circle. This side exactly, this side is opposite to angle C. So this is how we do it. We do R3 equals area of this triangle. You'll find the area of this triangle divided by S. You'll add all the three sides. You'll divide them by 2 and then S minus C. Okay, so you'll find the side C, small c, this would be small c, and this is how you will find the radius 3. Okay. Similarly, if you talk about this one, you will be using B in that case, and it would be simple. It would become for R2. Yes. Any confusions with these three? Any doubts? Please feel free
No,
to
ma'am.
ask me. Okay, Ahmed, what about you?
No.
Okay, very good. All right, then we are almost done. We just need to talk about a few more things. And then we would be in the position to solve the questions. Okay. The next thing is we have another application of trigonometry. So we can use trigonometry for finding the angle of elevation and angle of depression. Now, what exactly is the angle of elevation and angle of depression? Okay. Let's say you have two objects. Okay. At the moment, we're talking about angle of elevation only. Okay. So we have two objects. This is the first object and this is the second object. The angle of elevation would be the angle this. Okay. So basically you'll make a line between the two objects. They would be on different heights. And then you'll find the angle between that line and the horizontal line. This would be the angle of elevation. This man would have to raise his head to this much angle, and then he would be able to see the object. Okay. And the angle of elevation would be same as angle of depression for these two objects. Now, what would be the angle of depression? I'll tell you. We'll make a dotted line here. At the moment, just forget about this one. Just forget about this object. Okay. All right. Now, this angle is the angle of depression. Why is it the angle of depression? Because let's say if there's someone up there and they want to see down, so they will see down by this angle. Okay, since they're seeing down, so it is called the angle of depression. And it would be same. Okay, can anyone tell me then why exactly they are same? Because we have two parallel lines and they're being cut by a transversal. So we know that these are the interior opposite angles. That is why they are going to be same. Okay, let's talk about some more scenarios and then it would be very clear to you guys. Let's talk about this one. Okay, what do we see? Now we see again two things. One is at the bottom, the other one is at a higher position. It would be angle of elevation for this girl and it would be angle of depression for the pilot. Okay. If the pilot wants to see down, he would have to bend down. So that is basically angle of depression. And if the girl wants to look at the pilot, she would have to raise her head. So that is why it is angle of elevation. But as I've told you earlier as well, both of these angles for two objects, they are going to be same because we have two parallel lines and they're being cut by a transversal, so the angles are going to be same. Yes, any doubts with this?
No, ma'am.
Okay, then we have one more scenario. Now it could be that you have several objects over there. So what is this? So this is a man, then we have an aeroplane, and then we have a cat. Okay, if he wants to look at the cat, he would be making the angle of depression. If he wants to look at the aeroplane, he would be making the angle of elevation. But certainly these two angles are different because they are for two different things. Okay, if I talk about the angle of depression from the plane, that would be same as the angle of elevation. Okay, it would be this angle and this angle would be same as the angle of elevation. And if I talk about angle of elevation from the cat, so that would be this one. So this angle would be same as this angle of depression. All you need to understand is for two objects, one would be at a higher point, one would be at a lower point. So for the lower object, in order to look at the higher one, he would be, or that object would be making the angle of elevation. And the object that is placed at a higher position, for looking at the lower object, he would be making the angle of depression and both those angles would be same. Yes, Ahmed, any doubts in this? Any confusions?
No.
Okay. So let's talk about the questions now. Okay, here we have some questions. Okay, it says the measure of the angle of depression of an airport as observed by a pilot while flying at a height of 3000 meters is 30 degrees. How far is the plane from a point direct over the airport? Okay. This is what you need to calculate. I'll make the scenario. So we have an aeroplane, and it says the measure of angle of depression of an airport as observed by a pilot while flying at a height of 3000 meters. Okay. And we need to make the airport. So let's say this is the airport. So they're talking about the angle of depression. Angle of depression would basically be this is the line. This would be the horizontal line. So this is going to be the angle of depression. Okay, this is what we have just discussed. This would be the angle of depression, this one. Okay, so it could be that the aeroplane is all, look at this. This is a better example. So this would be the angle of depression. I'm just trying to make up the scenario. Okay. Right. So let's talk about this question over there. The angle is 30 degrees. Okay, what do we know? It is flying at a height of 3000 meters. Okay, the height is 3000 meters. So this means that this length is going to be 3000 meters. What do you need to find? How far is the plane from a point direct over the airport? Okay, let's say this is the airport. Okay. Let's assume this is the airport. Now the question is saying how far it is from a point direct over the airport. So what do you think? Which length are they talking about? Are they talking about length 1 or length 2? Think about it and then let me know.
They're talking about neither of those. They're talking directly, so it will be directly vertical.
No, we already have the directly vertical height. We already have this 3000 meters. Okay, we have that already.
Oh, okay.
Okay, yes, you are right. Anyone would have thought that way. Okay, what do you think? Yes, I got your answer, and your answer is correct, Ahmed. What do you think, Saad? So, would it be L2 or L1? It would be L2 basically. I'll read the statement again, and then you would understand. Okay. It says, how far is the plane from a point direct over the airport? So basically, at the moment the plane is at this point, and this is the ground level, and this is the airport. Okay, so he is talking about this length L2. Are you getting this?
Yes, ma'am.
Okay, very good. Now he's talking about L2. What do we have? We have that 30 degrees, we have this 3000, and this would certainly be 90 degrees because that was the height and this is the base. Okay, that is good. What would be this angle?
This would be 30.
Very good. Okay, very good. Because we know that the angle of depression is same as the angle of elevation. If not that way, then you can understand it this way. We have two parallel lines. They are being cut by a transversal. So these two angles would be same. If not this way, then if that is 30 degrees, this is going to be 60 degrees, 60, 90, and then this would be 30. Okay, so you can think about it through multiple ways. All right. Okay. Now we need to use simple trigonometry, and we need to find L2. So what is that? We can use the 30 degrees angle. That would be better. Okay. Now we have tan. We know that tan theta is equal to perpendicular over the base. So what is the perpendicular side? The perpendicular side is 3000 meters divided by the base, which we need to find. Okay. So what is going to happen? I can just take the base over there and I can do 3000 divided by tan 30 degrees. Yes. So can anyone tell me the answer? Okay. Now if I show you the options, you'll understand one thing. Okay. One thing is clear, that this is how we'll do it. Yes, that is good. But excuse me, now we need to talk about how to find this tan 30, because we would not be having a calculators. Okay. What do we see? The answer is not in decimals. Okay. The answer is in this form. So I'll share that PDF again. Through that PDF, you guys would be able to find the value of tan 30 easily. Okay. So at the moment, I'm telling you tan 30 is under root 3 by 3. You can either write it this way or you can write it this way, 1 over under root 3. The values are same for both of them. Okay. And in that PDF, it is 1 over under root 3. But the numerically, the values are same. It is 1 over under root 3. Okay. So you know that once you'll plug in 1 over under root 3, this would give you 3000 under the root 3. Okay. So the answer is going to be B. Yes. Any doubts for the first one? Anything that you have not understood?
No, ma'am.
This is important. Okay. This is important. You need to take in account this thing, that you have to learn these. Okay. The next question says, in a triangle ABC, A is 11, B is 9, C is 19, which angle is the smallest? So alpha is basically for A, beta is for B, and gamma is for C. Okay, so yes, now you need to think about the smallest angle using the side. So what do you think? Which side would be used for understanding this when they are saying smallest angle? Okay.
B.
B. Who said this? I could not hear you.
Me.
Okay. Ahmad, I suppose. All right. So yes, the answer would be B. Why? Let's make a triangle and understand that. So let's say this is a triangle. Okay. Now this side, let's allocate the side using this. This is B, then this is A, and then this is C. So what do we see? We should understand this, that if the opposite side is big, the angle would be comparatively bigger, right? If C is the biggest side, then this angle C would be the biggest. If small b is the smallest side, this angle B would be the smallest. And if A is in the middle, then this angle capital A would be greater than B, but it would be less than C. So you need to remember that angle and side, they have a direct relationship. If your side is bigger, your angle would be bigger. If your side is smaller, your angle would be smaller. Okay. So we're looking for the smallest angle. We look for the smallest side. So it would be beta. That is it. Yes. Any doubts with this, Saad?
No, ma'am.
Okay, very good. Now I would want you guys to help me with this question. It says, find the distance of a man from the foot of a 200-meter high tower if the angle of elevation of its top as observed by the man is 60 degrees. Okay, here's the question. Right. Now basically we have a tower.
Yeah, you could use the same triangle as the
Yeah, exactly.
BCA.
Sorry, which one? This one?
Yeah, you could use this as well. The triangle.
Yeah, exactly. We need to use
A
any.
would be the man. Yeah.
Exactly. Yes, yes, yes. That is correct. Okay. Very good. Yeah, but let's make the diagram here because just so it's clear. But yes, you are right. Very good. So this would be a tower, and then you have the man here, somewhere here. Okay. And what exactly is the question saying? We need to find the distance of a man from the foot of a 200-meter high tower. This is 200 meters. You need to find out this distance x, and what do we know? If the angle of elevation of its top as observed by the man is 60 degrees. So this would be the line. This is the top of the tower, and this would be the angle of elevation, and that is 60 degrees. That is it. Okay, so again you need to find the base. You can use the same formula and find it out quickly. Okay, and then you can just solve it, and the answer is going to be A. All right. Okay, this was a similar question. Let's try covering more questions. Okay, now what is this? It says sine square theta by 2. Now this is a half angle
B.
formula. Yes, it is a half angle formula. Very good, but it's not like the ones we have done today. It is the old one, so it would be B. Saad, do you know these formulas?
No, ma'am. I don't think so.
Okay, I'll quickly write it down. So you would be familiar with, okay, so you would be familiar with sine theta by 2. You can just search them. They are called half angle formulas. Okay, and you would find them in your FSC book as well.
Yes,
1
ma'am.
minus cos theta by 2. Okay, this is the original formula, and this is the question. So you need to square both sides, and this would be cancelled. So that is why the answer is 1 minus cos theta by 2. Are you okay with it?
Yes, ma'am.
Okay. Very good. Let's talk about some more questions. Okay. Now it says in a right angle triangle ABC with the right angle at B, which one is true? Yes. The right angle is at B. So the hint is Pythagoras theorem. Okay. Let's say we have a triangle. This is A, B, and C. They are saying right angle is at B. This is the right angle. This side is A. Then this side is B, and this side is C. Okay. So which one would be correct? Saad, do you remember Pythagoras theorem? So we square two small sides, and that is equal to the square of the biggest side. Okay. A and C are the smaller sides. So A squared plus C squared would be equal to B squared. This is the Pythagoras theorem, and using this, the answer is very obvious. It is C. Are you okay with it?
Yes, ma'am.
Okay. And what about you, Ahmed? Is that okay?
Yes.
Okay. Then it says which one is true. Okay, we have just seen the cosine rule. We know they're talking about the cosine rule. So what exactly it is? This is not true. What is the cosine rule
D.
exactly? Yeah, D. Very good. D would be the answer. Okay. So this and this, they should be same. The remaining two, they are added, and then we have a minus sign. Okay. So Saad, please try getting comfortable with these formulas. Once you're comfortable with them, you would be able to do them easily. We discussed them today in class as well, okay? I'll quickly show you. Yes, these, okay? These. The law of cosine.
Yes.
They were basically asking you about the law of cosine. Okay.
Yes, ma'am.
All right. Very good. Okay. Now let's do this one. So it says the measure of the angle of elevation of a kite is 30 degrees. The string of the kite is 250 meters long. If the say in the string is 5 meters, find the height of the kite. Okay, so this is basically just about the elasticity in the string. Okay, do not get confused with that. Okay, so it is this. So we need to measure the angle of elevation of a kite. The string of the kite is 250 meters long. So let's say this is someone who's holding the kite, and then this is your kite, it's there. This is the kite, okay? And we have this length as 250 meters long. You need to find the height of the kite. You need to find out this height, and the angle of elevation is 30 degrees. Okay. All right. Now, what exactly is this? So basically here we have okay, I got a message from Saad. All right. Okay. So let's do it together then. Okay. It says the measure of the angle of elevation of a kite is 30 degrees. The string of the kite is 250 meters long. If the say in the string is 5 meters. Okay. I'm sure that this wording would be new for you, but what they're trying to tell you is that the original length of this triangle is going to be 250 minus 5, because 250 meters is the length of the string, okay? And then we have some extra part in the string which is basically not used, so that is of 5 meters, okay? So it would be 250 minus 5. And now it is a simple question, but this was the only trick. And some of the questions in these PDFs are from books as well, just so we are able to practice the concepts as well. Okay, so that is why the wording is a bit different. In past papers, in those questions in the exam, the examiner is not going to use such weird terms. Okay, but for this question I'll explain you again. The string is originally 250 meters long, but there's some extra part. Okay, if you have ever used a tape or stuff like that, you would be knowing that there is some part of the tape or some part of the string of if you have used a thread as well, in that case as well, it has some plastic wrap to it, and that's just for your reference. Okay, they're just writing down the name of their brand and everything on that. So that part is a 5 meters, so that would not be included, so it would be 250 minus 5, and this would be your right angle. Okay, Saad is back. This would be a right angle. Now, how do we find the height? You can use sine. Okay. Yes. Saad, are you back?
Yes, ma'am. Sorry.
Okay, so yeah, no, it's okay. So I was explaining this question. I'll explain it again. It says the measure of the angle of elevation of a kite is 30 degrees. Okay, so there's a kite and then there's some person, and the angle of elevation is 30 degrees. So it is 30 degrees. The string of the kite is 250 meters long. Okay, now the string originally is 250 meters long. If the say in the string is 5 meters, this means that these 5 meters are the extra 5 meters and they are not being used at the moment. So the original length of the string that is being used would be 250 minus 5. That would be 245. And you need to find the height. Okay. So how do we do it? We have three trigonometric formulas. Which formula can we use here, Saad? Do you know? We can use sine. Okay. Sine 30 degrees equals perpendicular side over hypotenuse side. Perpendicular side would be the height. Hypotenuse side would be the side opposite to the right angle. So it would be sine 30 into 245 equals the perpendicular side. So you can just find the value and the answer is going to be 122.5. Yes, Saad and Ahmed, any doubts with this question?
Yes, ma'am.
Okay, all right. Then it says, which one is known as the hero's formula? So can anyone tell me? We have discussed
C.
that. Very good. It would be C. Excellent. Here's the hero's formula. We have used that for finding the area of a triangle. So it's this one. Very good. Okay. It would be C. Okay. And then we have this one last question. It says, in our triangle, A is 17, B is 19, and C is 15. The largest angle is, now it's very easy. What would be the largest angle? B. Very good. Okay. So the largest angle would be opposite to the largest side. So it would be B. Very good. Okay. Yes. So we have done these questions. Any doubt with these or any doubts in the concepts we have discussed? Anything that you have not understood? Okay. What about you, Saad?
I said no.
Okay. Actually, I was not able to hear you properly. I thought this is Ahmed. Okay. So Ahmed, are you clear with this?
Yes, that is correct.
Okay. So I'll stop the recording, and if you have any questions, you can just ask me.